Hi everyone and welcome to my YouTube channel. I am Ruz Beshad. This is the fourth part of the series on how to develop a software application. If you've been following this series of videos, you know that in the last part we set up the models project. In this part, we'll create the service layer, which is the heart of the software application and is responsible for ensuring the system's business rules. If you haven't watched the previous videos of this series, I recommend you to do so before following this part, as they are prerequisites for this video. So let's make a start. Run Visual Studio and open the Northwind solution if you haven't already. You see that we've already created the Northwind.service project when I explained the multi-layered software architecture in another tutorial video. It's a class library that is supposed to act as a service layer and includes all the functions to support CRUD operations as well as guaranteeing business rules for the software application. Of course, you should keep it in mind that many of the business rules, including validation of entities, have been implemented using data annotations and get checked by the model binding of the ASP.NET Framework. Now it's time to write our logic for CRUD operations. The best way to achieve this is to first define a contract, that is an interface in C# which contains definitions for a group of related functionalities, and then create a service class that implements the interface. The interface is an abstract object that defines what operations or behaviors it includes, and any class that implements that interface must provide an implementation of the members defined in the interface. You'll see in the next videos that using interfaces is an excellent way to make components of a software application be loosely coupled. And when dependency injection comes into play, they are excellent match for doing this, plus separation of concerns. Alright, let's expand the Northwind.service project and delete class 1. Then right-click on the project and select the Add New Item option. On the Add New Item dialog box, select the interface option from the middle pane and give it a name. I'd rather name it iEntity Service. Finally, click on the Add button to add the interface to the project and close the dialog box. Now let's make a number of changes to the interface declaration. First, add public modifier to make it a public interface. Second, make it generic by adding a type parameter in front of it. Third, add a constraint to limit the type parameter to the domain classes. Finally, derive it from iDisposable interface. I'll explain the reason for the latter shortly. Okay, it's time to add methods to our interface. Let's start by adding getById method. This accepts the ID of an entity as its parameter and return the entity with that ID. So we'll have But this doesn't work for customer and order detail classes. If you followed my previous video, which was about setting up the models, you'd know that we couldn't replace the primary key of these two classes with the inherited ID property. To fix the problem, one approach could be adding a specific code for customer service and order detail service classes when doing a specialization for them. Another approach could be creating a new method in the current interface, which is my preference. So, as you can see, this method accepts a variable number of parameters of any type. So it perfectly fits customer class with a key of type string, that is, the customer code property, and also order details class with a composite key. The benefit of this method is that it can be used for retrieving entities by their alternate keys too. The next method is called getAll, which returns all entities of the specified type. So we'll have I'd like to add the third form of get method called getByParam. This method will take a parameter or parameters containing conditions and other information and returns a list of entities that meet those conditions. So we'll have the type or data structure for the parameter is still unknown, and I'll talk about it in another tutorial video. The next and most important method is called save, which is responsible for storing the entity data in the database. So as you see, it takes an entity as its parameter and returns the modified version of it. The last method is a Boolean one that takes the ID of an entity and checks for existence of that entity. Again, it doesn't work for customer and order detail classes, so let's add an overloaded version of this method like the following. This version of exist method works with the alternate keys of the entity. Alright, we are now ready to implement our interface. So right-click on the project and select Add Class option. Name it Entity Service, and then click on the Add button to add it to the project and close the dialog box. Now make these changes to the class declaration. First, add the public modifier. Second, derive it from the iEntityService interface. So you also need to add type parameter to the class to make it generic. And finally, add the same constraint to the class that you applied to the interface. After all these changes, you see the iEntityService interface marked with a wavy red line underneath that indicates the interface has not implemented yet. So click on the Quick Actions menu and select the Implement Interface with Dispose pattern. This option generates methods with empty body along with the code to support iDisposable. Now move the disposed value declaration statement to be near the related code block and wrap it in a code region to make the code tidy and clean. The reason for iDisposable support is that sometimes our software components use unmanaged resources like file handles or database connections. Such components should release their resources as soon as they finish their work. Implementing iDisposable interface and calling its dispose method is one way to achieve this goal. Before putting code in the body of each method, let me remind you that the service layer is usually an intermediate layer between the repository layer and its consuming component, like a controller class in an ASP.NET Web application or Web API. Because we haven't created the repository layer yet, we have to access the context class directly in our service layer at this time. So let's create a private field in the class to hold an instance of the Northwind context class. Then create a public constructor that initializes the newly added field with a reference that is passed as a parameter. Now it's time to write code for each method. Let's start with the getById method. In order to get an entity with its ID, we need to go through the context class to reach the related dbset property, and because we have defined our class as a generic one, we can use such a statement. Then we can use the find method of the dbset with the ID parameter to get the entity and return it as the result. So before going further, let's make a number of improvements to our code in this method. First, I'd like to remove the unused variable from here. Second, it's better to replace this part with a dbset member in the class. So let's declare a new field name _dbset. And initialize it in the constructor. Now we can replace that part of the statement with the newly added field. So we'll have, you see that the method has become cleaner, more readable, and compact. The next modification that I'd like to make is very important. This method can be a long-running process depending on the speed of database, network, and other factors. This is going to block the current thread and make it unresponsive until it gets the result. Such method cannot be serving other requests. Having asynchronous and multitask code is a must in modern programming. So let's modify our method this way. First, use the asynchronous version of the find method instead. Second, with async method, you need to apply the await keyword. This new statement is awaiting instead of blocking. Methods, including await keyword in their body, need async modifier before their name. So, the third change is adding async modifier to the method. The fourth modification is the returning type. Asynchronous methods usually return a task, so the final modification is renaming the method by adding the async word to the end of method to reflect that it's an async method now. you need to modify the getById method in the iEntityService interface accordingly. Before going back to the class and writing code for other methods, let's modify the remaining method in the interface like what we did for getById. So add async as suffix to the name of methods except exist methods and change the type so that they return tasks. Note that the async suffix in a method name is just a marker to indicate that a method is going to be an asynchronous method. Also modify the corresponding methods in the class. Now it's getAllAsync's turn to be completed. Put this code in the body of this method. As you can see, we've chosen not to track our entities by the context class. There are several reasons for this. Perhaps the simplest explanation is that we want to manage saving the entity back to the database by ourselves. You'll see it shortly when I complete the save method. The next method is getByKeyAsync. It's very similar to getByIdAsync method. So let's borrow the code from that method and change it slightly to fit for this method. Let's skip getByParamAsync method at this moment as we need to create a special data structure for its parameter, and I'll talk about it in another tutorial video. The next method is saveAsync. This method is very important in terms of business logic, in particular validation logic. We don't still need to put any validation code here, as in ASP.NET applications, validation is automatically checked by the framework. But let's put some direction about validation at the beginning of the method just in case of using frameworks other than ASP.NET. When validation is passed, the next thing is checking the entity state so that we can decide what action we need to take. All of these statements will attach the entity with the appropriate state to the context class if it hasn't already. The next block of code will update the database with the changes made to the entity and reset its state only if the entity has changed. Finally, it returns the updated version of entity. Now we have two exist methods left. For the first one, I'd use this code. And for the second one, I'd use a different approach. One way of improving this code could be using find async instead of find, and so you'd have to use await and async modifier, and also change the return type to task, and perhaps want to change the name of method by appending async suffix by convention, etc. I leave it to you as your choice. The last thing that you should not forget is to dispose the context class when the dispose method gets called. Remember to save your work and build the project to make sure there's no compile error in the code. Well, as you can see, we wrote the entity service class in a very generic way that meets almost all the requirements for all domain classes. As a final point, I'd like to remind you that if a specific function is required for any of the domain classes, you can create a service class with the corresponding name for that particular class, which is derived from entity service and includes the implementation of that function. This is kind of a specialization. Alright, we are now done with our work on the service layer, and I hope you've enjoyed it. In the next video, we'll start our work on the RESTful API and see how to use and consume the service layer from there. If you have any questions regarding the content of the videos, I'd be happy to discuss it with you in the comment sections. If you like this video, please do not forget to give it a thumbs up and also subscribe. Thanks for watching. I'll see you in the next video soon.